Welcome back to another explainer. Okay, let's dive into this, because today we're looking at something that's literally changing how AI interacts with the real world. We're unpacking this seriously powerful open-source Go tool called swag2mcp. You see, when we're building AI agents, we always hit this same annoying wall. Large language models are brilliant at reasoning, right? But they're kind of trapped in a box. So swag2mcp acts as this ultimate bridge, connecting any REST API directly to your LLMs using the Model Context Protocol.
Look, the developer pain point here is painfully real. The old way of doing things? Absolute mess. Every single time you want an LLM to interact with an API, say just to look up a user's account or create a support ticket, you have to write all these custom tool schemas. You're manually wiring up authentication, you're validating parameters, parsing responses. It turns every simple API call into an exhausting integration project. And why? Because fundamentally, that incredible AI reasoning power is totally disconnected from our real-world systems.
And that brings us to the stark reality of the situation. LLMs simply cannot call APIs natively. Without you writing an endless sea of custom glue code, an LLM absolutely cannot trigger a deployment pipeline or, query your inventory system. It's completely dependent on developers manually hand-coding every single interaction path.
But hey, that is exactly the paradigm shift we're looking at today. Enter swag2mcp. It's a clever little portmanteau of Swagger and MCP, and it runs entirely as an MCP server. It literally takes your existing OpenAPI, Swagger, or Postman spec files and automatically transforms them into fully functional MCP tools. I mean, zero glue code required. You just point it at your spec file, and it handles the rest.
Now, what's really interesting about this slide is that number, 14. By simply feeding swag2smc your API spec, it instantly exposes 14 unique SMC tools to your LLM. And we aren't just talking about basic endpoint callers here. These tools cover the entire API lifecycle: discovery, navigation, search, inspection, authentication, the whole shebang. Your LLM suddenly has this complete out-of-the-box toolkit to understand and use your API exactly the way a human developer would.
And since it's actually built for the real world, it handles security like a champ, sporting 8 built-in authentication methods. It's got you covered from basic public APIs all the way to complex OAuth 2 flows, API keys, and even custom shell scripts that spit out JSON tokens. Plus, it resolves environment variables and automatically caches your tokens. You literally configure this once in a YAML file, and your LLM never has to stress about the auth handshake ever again.
But giving an LLM access to thousands of endpoints is pretty useless if it can't actually find what it's looking for. That's where the Blooge-powered full-text search steps in. Instead of forcing the LLM to blindly click through this massive tree of specs, which, let's be honest, just eats up tokens and time, it can just use natural language. Using field filters, Boolean operators, and fuzzy matching, the LLM tracks down exactly the endpoint it needs in literally milliseconds.
What I really love is that this tool is fundamentally designed to be AI first, meaning it has these great built-in safeguards. For instance, there's a 10-second invoke cooldown per endpoint. That stops an overeager LLM from hammering your servers and triggering a rate limit ban. It handles massive API responses by saving them straight to disk. And the best part? If something goes wrong, it spits back an LLM error with human-readable next steps. It's basically coaching the LLM on how to fix its own validation mistakes on the fly.
All right, moving into Section 1, Real Session Demo. Open code plus the swag2mcp, MCP.
Let's step out of the theory for a second. Let's move to and see how this builds inside a simulated terminal environment using the OpenCode CLI agent. The flow here is just incredibly natural. First up, the LLM uses the speclist tool to discover what APIs it can even access. Then, when you ask it to find available pets, it hits the search tool. And before doing anything crazy or risky, it runs inspect on the get schema to actually understand the parameters it needs. Finally, it uses invoke to execute the call, bringing back available pets like, say, Rex the dog. All of this driven by just a simple English request.
And no way does it stop at just reading data. It writes data safely too. You just type, add a new pet named Buddy, a 1-year-old cat. The LLM automatically inspects the post body requirements, maps out the data, asks you for a quick safety confirmation, and fires it off. Boom! A 201 created status comes back, confirming that the AI successfully navigated the schema and safely altered the database, entirely on its own. It's like magic.
Which brings us to Section 2, Architecture Snapshot, under the hood.
So, everything we just saw happen, that took under 2 minutes without writing a single line of integration code.
Let's quickly look at how this top-down flow actually works. It starts with this slick dual interface. It acts as an MCP server for your agents, sure, but it also has an interactive terminal UI for humans to explore APIs manually. Beneath that is the service layer, which handles all your search, inspection, and auth. Then you have the index and HTTP client, all being fed by the foundational spec parser that reads your OpenAPI files. It's just a super clean, efficient pipeline.
By bridging that gap between language models and real-world APIs, you're essentially transforming any REST API into a first-class citizen in your AI workflows. You completely bypass the need to maintain tedious tool definitions every time an API updates. So the crucial point is this: stop writing glue code. Start talking to your APIs.
Seriously, if you're building AI assistants, automating DevOps, or you're just plain tired of manually wiring up endpoints for your agents, this is a tool you absolutely need in your stack right now. It's fully open source under the MIT license, and it's sitting right there on GitHub. I highly encourage you to pull it down, point it at your Swagger file, and just see what happens when your LLM is finally unleashed on your real-world systems. It makes you wonder, what will your AI build when it can finally reach outside its box? Thanks so much for joining me on this explainer, and I'll catch you next time.